What's up guys, welcome back to ONeill Code. Today we have a requested video that goes over the knapsack problem. The question would go something like this. Given weights and values of n items, put these items in a knapsack of max capacity W to get the maximum total value in the knapsack. You cannot split items. Since we were unable to split the items, this is known as a 0-1 knapsack problem. In some instances, you are allowed to split the items to complete the problem, but we won't be going over this version since I think the 0-1 knapsack problem is more commonly asked. So the first thing you'll be given is a capacity W. In this example, it will be 6. Next, you will be given two arrays. One will hold the weights while the other will hold the corresponding values. Here we are given the weights 1, 2, 3, and 4 with the corresponding values 1, 3, 4, and 6. Now the point of the problem is to find the highest combination of values we can fit into the knapsack. Since the capacity of our knapsack is only 6, we can't put weight combinations higher than that in the knapsack. So for instance, we can't put the value 4 and 6 in there because the weight would be 7, which is higher than 6. And then lastly, there's only one of each item, so you can't put in 6 different weight 1 items. So now that we understand the rules, let's see how we can solve this problem using dynamic programming. First, we're going to create a two-dimensional array named T that's sized n plus 1 by w plus 1. So for this example, it's going to be a 5 by 7 array. We're going to use this array to compute the different sub-problem states needed to eventually get the answer. To begin the process, we're going to iterate through the whole 2D array using I and j values. I will represent the rows and j will represent the columns. So looking at this demonstration, the numbers on top of each column will represent the j values, but more importantly, they will represent the weight. Each column is numbered 0 to 6 and represent each weight respectively. Now that we understand the 2D array, let's see how we can give it values. The first part of logic, we are always going to check if I or j is equal to 0. If so, we are going to place a 0 in that location. So we start off at location 0, 0. Since both I and j are 0, we are going to place a 0 in that position. We next move on to position 0, 1. Since I is still 0 here, we are going to again place a 0 in that location. If you notice, if we iterate through the rest of the first row, I is always going to be 0. Therefore, the whole row is going to be given the value 0. So once we iterate through that whole first row, we're going to move down to the second one. This puts us at position 1, 0. Since the j value is 0 here, we're going to again give this position a value 0, but we move on to position 1, 1 in the array. So here's the first spot where both I and j are non-zero and where we get to move past the first part of our logic. The following logic may seem tough, but it's actually super easy. So we're first going to have to check if the weight in the weight array is greater than j. We're going to look at the weight array at position I minus 1. I mashed up the weights and the values with the corresponding rows to help better visualize the I minus 1 logic. So if the weight is greater than or equal to j, we give it the value at position I minus 1j. That is a position directly above our current position. So we look up one spot and take that value. Easy enough. But if the weight is less than or equal to j, we take the max of two values. The first is the same one we just looked at, the position right above it. The second is the one right above it, and then to the left, the weight value amount of times, and then we add our corresponding value to it. So let's start at our current position 1, 1. We need to check if the weight is greater than j. Since both the weight and j are equal to 1, we need to look at the last part of the logic. We need to find the two values for the max. So the first one's going to be looking at the position right above our current position. It would be position 0, 1, which has a value of 0. Then we need to look at the spot right above it, but we also need to move to the left one spot since the weight is 1. So we move up 1 and left 1, bringing us to position 0, 0. There's a value 0 in this spot, but we also need to add the value for the weight 1, which is 1. So we add 0 plus 1 and get 1. That means we take the max of 0 or 1, which gives us 1 for that position. Next we move on to position 1, 2. Neither I and j are 0, so we go past the first if statement. The weight is still 1 for this entire row, and since j is 2, it doesn't enter the second if statement. This means that we do the same thing we did for the last position. We look up one spot and to the left one spot since the weight is 1. That brings us to position 0, 1, which has a value of 0. We add it to the corresponding weight value, which is 1, and we get 1. We can do this the rest of the row and we get the same result the whole way. Once we get to the end of the row, we can move on to the next. This will put us at position 2, 0. Since j is 0 here, we give it the value 0. Now we can move on to position 2, 1. Since neither I or j are 0, we move past the first if statement. Now for this row, the weight is going to be 2. Since 2 is greater than the j value, which is 1, we enter the second if statement. In this one, we just look at the position right above it and take the value. Since the value above it is 1, we give it the value 1. Now move on to position 2, 2. I and j are both non-zero, we move past the first if statement. Since the weight is 2 and it's not greater than j, which is 2, we move on to the last statement. We move up 1 spot and 2 spots to the left since the weight is 2. This brings us up to position 2, 0, which is a value of 0. We add that to the corresponding weight value, which is 3, and give our current position the value 3. We move on to position 2, 3 now. Since the last position we found skips the first two if statements, we can do the same here. We move up 1 spot, then 2 spots to the left. The value here is 1. We add the corresponding weight value, which is 3, to it, and this gives us 4. Then we can give the current position the value 4. We can do the same for the rest of the row, and we end up getting 4 until the end. Now we can move down to the next row, and this puts us at position 3, 0. Since j is 0 here, we can give it the value 0. The weight for this row is 3, so for the next two positions, we know that we can just take the value above it because they are less than 3. Once we get j equals 3, we can move down to the last statement in the logic since the weight is no longer greater than j. We move up 1 spot, then 3 spots to the left. The value here is 0, so we add it to the corresponding weight value, which is 4. We place the value 4 in the current position and move on. Now we are in position 3, 4. We look up 1 spot and then 3 spots to the left. We find the value here is 1 and we add 4 to that. This gives us 5 and we can place this in our current spot. We do the same for the next 2 spots and we get the values 7 and 8. Now we can move down to the last row. Since j is always 0 in the first column, we can place a 0 here. The weight is 4 for this row, so we can take the position above it until we get j equals 4. Once we get there, we can move down to the last statement in the logic. We look at the position above it and we do 4 spots to the left. The value is 0, so we add that to the corresponding weight value, which is 6. We then place it in the current position and move on. This gives us position 4, 5. We look up 1 spot and 4 spots to the left and land on a value of 1. We add 6 to it and place 7 in the current spot. We finally reach the final spot in the array. We look up 1 and 4 spots to the left and land on a value 3. We add 6 to it and place the value 9 in the final spot. And there you have the full array and the final answer of 9 because it's the highest value. And there it is, the knapsack problem. After going through the whole array, hopefully you see how easy it really is. But if you do have any more questions, just leave it in the comments and I'll try to answer as quick as I can. If you want me to create a Java video explaining how to write this in code, I can create that as well. Now, if you liked the video, please give it a thumbs up. And if you want to see more content from me in the future, hit that subscribe button. Peace out.